These are 9 symptoms of a failing VVT solenoid, a small component that controls your engine's valve timing and, when it goes bad, creates problems ranging from annoying to potentially catastrophic. Most drivers never think about the VVT solenoid until something goes wrong. But here's the thing, every major automaker uses this technology now. Toyota calls theirs VVTi, Honda has VTEC, Ford uses TIVCT, and BMW calls it VANOS. If you've driven a car built in the last 20 years, you've relied on variable valve timing, which means you've relied on these solenoids working properly. Today we're breaking down exactly what happens when they don't, covering the warning signs, the reasons they fail, what repairs cost, and whether this is something you can tackle yourself. Catching these symptoms early can mean the difference between a $200 repair and a $3,000 engine rebuild, so let's get into it. Before we talk about what goes wrong, you need to understand what this thing does when it's working right. The VVT solenoid, sometimes called an oil control valve, is an electrohydraulic actuator, which is a fancy way of saying it uses electrical signals to control oil flow. Your engine's computer sends pulse signals to the solenoid, which then directs pressurized engine oil to something called a cam phaser, and that phaser rotates your camshaft relative to the crankshaft, changing exactly when your valves open and close. 25 to 62 crankshaft degrees is the typical adjustment range. That might not sound like much, but it allows your engine to optimize valve timing for completely different situations, whether that's fuel economy when you're cruising on the highway, maximum power when you're accelerating to merge, or smooth operation when you're sitting at a stoplight. The benefits add up fast. VVT systems deliver roughly 4.5 to 7% better fuel economy, up to 7% more peak power, about 5% more low-end torque, and dramatically reduced emissions, with some systems achieving NOx reductions of up to 24%. When this solenoid fails, you're not just losing a small component, you're losing your engine's ability to adapt to what you're asking it to do. Symptom number 1 is the check engine light, and this is usually the first sign something's wrong. When your VVT system malfunctions, your engine computer sets specific diagnostic codes, with the most common ones starting with P0010, P0011, and P0012 for the intake camshaft, and P0013, P0014, and P0015 for the exhaust. Reading these codes tells you a lot about what's happening. Codes ending in 0, like P0010, indicate electrical problems with the solenoid circuit. Codes ending in 1 mean the timing is stuck over advanced, and codes ending in 2 mean it's over retarded. Understanding which code you have tells you whether you're dealing with a wiring issue or a mechanical failure. Symptom number 2 is rough idle, and a bad VVT solenoid disrupts valve timing at low engine speeds in ways you'll definitely feel. The engine shakes, RPMs fluctuate by 100 to 300 at idle, and the car feels unstable when you're stopped at a light. What's happening here is that the VVT system should essentially deactivate at steady idle, but a defective solenoid won't close properly, allowing erratic oil flow to the phaser. Many owners notice this gets worse once the engine reaches operating temperature, and that's because some solenoids work fine cold but fail when they heat up. Symptom number 3 is poor fuel economy, and without proper VVT function, your engine can't optimize valve timing for cruising. 2 to 5 miles per gallon is the typical loss owners report. Run the math on that over 15,000 miles per year, and you're wasting roughly $200 to $300 annually in extra fuel costs. Over 2 years, the fuel savings alone pay for the repair. Symptom number 4 is loss of power, and VVT systems provide different timing profiles for low RPM torque versus high RPM power. When the solenoid fails, you lose that adaptability entirely. Throttle response feels delayed. The engine bogs under load, especially climbing hills, and acceleration feels sluggish, particularly from a stop or when you're trying to pass someone. 15 to 30% power loss has been reported in severe cases, and that's because the engine computer may actually limit output when it detects the VVT system isn't working. Symptom number 5 involves engine noises, and a failing VVT solenoid often produces sounds you can identify if you know what to listen for. Rattling at startup in the first few seconds of a cold start indicates the solenoid screen or oil passages may be restricted. Ticking at idle or low speeds means the solenoid is struggling to regulate oil flow. Knocking or pinging during acceleration is the serious one, and that's pre-detonation, meaning fuel is igniting before the spark plug fires because timing is off. If you hear knocking, don't ignore it, because continued operation with knock can cause serious engine damage. Symptom number 6 is failed emissions test, and VVT systems reduce emissions by optimizing combustion. combustion. When the solenoid fails, combustion efficiency drops, unburned fuel increases in the exhaust, and emissions go up across the board, including nitrogen oxides and hydrocarbons. Even if your check engine light weren't already causing an automatic failure in most states, your vehicle would likely fail the actual emissions measurements anyway. Symptom number 7 covers starting problems, and this manifests differently depending on conditions. Prolonged cranking happens because the computer lacks proper timing data, and in severe cases, the engine cranks but won't fire at all. Cold starts can be difficult because thicker oil struggles to flow through a contaminated solenoid, and some vehicles have the opposite problem where they start fine cold but struggle when warm because the solenoid fails when heated. Mechanics report cases where vehicles could only be started with the throttle pressed and would immediately stall when released. That's a classic VVT solenoid symptom. Symptom number 8 involves oil-related warning signs, and since VVT systems depend entirely on pressurized oil, oil problems frequently trigger or accompany solenoid failure. Low oil level means insufficient pressure for proper VVT operation. Dark, thick oil indicates contamination that's likely clogged the solenoid's internal filter screen. Wrong viscosity throws off the computer's calculations for how to pulse the solenoid, and you might even see oil leaks around the solenoid itself, indicating O-ring or seal failure. Dirty oil is the primary cause of VVT solenoid failure, and that tiny internal screen clogs easily with sludge and debris. Symptom number 9 covers misfires and timing chain noise. And beyond the core symptoms, you might experience engine misfires where timing discrepancies interrupt combustion, potentially triggering misfire codes alongside your VVT codes. Timing chain noise from improper lubrication is another sign, and the engine might feel rougher than normal throughout the entire RPM range. Ignoring VVT problems long-term in interference engines risks valve to piston contact, and that's catastrophic because it destroys both valves and pistons. Now that you know the symptoms, let's talk about what causes them. Dirty or contaminated oil ranks number 1 by far because sludge clogs the solenoid's internal screen and oil passages. Extended oil change intervals make this worse as contamination accumulates beyond what the solenoid can handle. 70,000 to 100,000 miles is the typical lifespan with proper maintenance, but poor oil care causes failures as early as 30 to 45,000 miles. Other causes include low oil level, electrical issues like wiring damage or connector corrosion, wrong oil viscosity, engine overheating, and normal wear over time where internal seals degrade, screens clog, and electromagnetic coils weaken. Certain vehicles have higher failure rates. GM's 2.4-liter engines in the Equinox and Terrain are known for this, along with Toyota's 3.0 and 3.3-liter engines, Ford's 5.4-liter 3-valve engines in F-150s and Expeditions, Kia and Hyundai 2.4-liter engines, and BMW vehicles with VANOS systems. If you're experiencing these symptoms, here's the diagnostic approach. First, retrieve your codes with an OBD2 scanner and note the freeze frame data, which shows engine conditions when the code's set. Second, and this is the part most people skip, check your oil before you do anything else. Verify the level, look at the condition, and confirm the viscosity is correct. Dark, thick, burnt-smelling oil needs to be changed immediately. And here's something most people don't know. An oil change resolves many VVT codes. $50 for an oil change should always be attempted before replacing components. If that doesn't work, you can test the solenoid itself with a multimeter by disconnecting the electrical connector and measuring resistance across the terminals. 5 to 20 ohms is what you're looking for, and most VVT solenoids test between 6 and 12. Infinite resistance means an open coil, which has definitely failed, and very low resistance under 2 ohms indicates an internal short. Either reading means you need a replacement. But here's the catch experienced mechanics warn about. Test both cold and hot because temperature-related failures are common. A solenoid may test perfectly cold but fail when heated, and some solenoids pass every bench test and still don't work properly in operation. Here's the good news about repairs. VVT solenoid replacement rates a 3 or 4 out of 10 on the difficulty scale, which puts it in DIY-friendly territory. On most vehicles, these solenoids are accessible from the top of the engine bay after removing plastic covers, and they're typically secured by 1 or 2 bolts, usually 10 mm, with an electrical connector. 30 to 60 minutes handles a simple replacement, average jobs take an hour to an hour and a half, and complex engines might need 2 to 3 hours. First-timers should add another 30 minutes to an hour. Costs vary by vehicle, with total replacement running $150 to $600 depending on your car and whether you go to a dealer or independent shop. Parts alone cost $50 to $200. Labor runs $75 to $270 based on the shop rate, and dealers typically charge 20 to 40% more than independent shops. For context, a Honda Accord runs around $226 to $361. A Ford F-150 comes in at $306 to $419, and a Toyota Camry costs $551 to $599. Here's what I want you to take away from this. If you're experiencing any combination of these 9 symptoms, whether that's the check engine light with VVT codes, rough idle, poor fuel economy, power loss, engine noise, emissions failure, starting problems, oil issues, or misfires, you likely have a VVT solenoid problem. Start with an oil change using the manufacturer's specified viscosity, and if codes persist after 20 to 30 miles of driving, replace the solenoid. This two-step approach resolves the majority of cases at minimal cost. Don't ignore it. A $150 to $600 repair today prevents a $1,000 timing chain job, a $4,000 camshaft replacement, or a $10,000 engine rebuild down the road. That's the complete guide to VVT solenoid failure. If this helped you diagnose your own vehicle, let me know in the comments what symptoms you were experiencing, and if you want more content like this breaking down exactly how your car works and what to do when it doesn't, subscribe. Thanks for watching.